Hi everyone, I am back in the classroom now for the month of June and I am very excited to be here. It just gives me a little bit of hope and excitement for when I get to see all of you next. So I hope you're all doing well at home and staying safe and healthy and getting some fresh air. It is beautiful outside these days. So yeah, I am going to teach you our next lesson for our final unit in math class. So our final unit is algebra. This is the biggie, the one that the division really wants to make sure that all of you get it and you know. It's called a foundational outcome. So it's foundation, like we need it kind of a thing. That's what that means. So if you want to get out a piece of paper and a pencil, I'm going to write on the whiteboard. Haven't done that in a while. So yeah, here we go. Start off with your title. We're going to dive into our first specific lesson on solving one-step equations. So that's going to be our title. One-step equations. So I'm sure you know what's coming next is two-step equations. That's going to be later in the week. But we're going to start with one-step equations. So before I get going on that, our unit is called linear algebra. Normally I would have taught you a bunch of stuff in math class already. This is one of our numeracy outcomes. So in math class, we would have gone over some of the kind of prerequisite stuffs, but I am just getting right to the good stuff because we don't have very much time left. But what linear algebra means is linear is a straight line, okay, straight, and algebra is solving for an equation, solving for an unknown variable. So when you solve for X, or you solve for Y, or you solve for Z, or M, or A, or B, solving for something that you don't know. That's what algebra is. So when it's straight, that means that when you plot something on a graph, you're ending up with a straight line. So we will get to that eventually, but just a little bit of information. That's what linear algebra means, okay? If you don't end up with a straight line when you graph something, that means you made a mistake, okay? That is not linear. So we are sticking with linear straight lines. So moving into now solving equations, we're starting with one step, and we need to always isolate the variable. Okay, you've heard me talk about this before. Even when we do like our surface area and volume, we're always trying to solve for the part of the equation that we don't yet know, and that's called the variable, and you always want to isolate it, get it by itself. So isolate the variable by performing the opposite operation. So this should be familiar to you, again, because, come on in. You can say hello, or I'm just recording a little lesson. Mrs. Perot is here. The opposite operation should make sense to you because, again, when you are trying to eliminate something, you want to do the opposite in order to do that. So here's a couple examples.
Hello. Just returning.
Oh, perfect. Oh, The Hobbit.
Yeah.
Awesome. Thanks. Okay, so here's our first example. Mrs. Pro is so cute. I like her. Who dropped off The Hobbit? Let me see. Maybe that was one that was taken out a while ago. I don't know. Well, thank you, whoever dropped that off. Okay, so this is our equation, okay? An equation has an equal sign. So there's something on the left and something on the right. And we are solving for this guy right here. So it's a P. It could be an X, a Y, as I mentioned before. It just happens to be a P. That's called the variable. So right now we have 4 being multiplied by P. Okay, again, when there's just two things side by side, that means you're multiplying them. So we need to isolate the variable, isolate P, by performing the opposite operation. So what's the opposite of multiplying? Mrs. Perot was here, she just left. She would probably shout it out. It's dividing, okay? So that's your next step. So 4p divided by 4, whatever you do to one side, you have to do to the other, right? So this should be the familiar part to you. So now our 4s, they don't just evaporate, remember, it actually turns into a 1 because 4 goes into 4 one time. So we could write 1p, or like I always say, if you have one apple, you have an apple, right? If you have one pencil, you have a pencil. You don't even need to put the 1 there. So I just like to leave that out then because it's a little bit more, like, makes a little bit more sense to me. So now you have to figure out what 68 divided by 4 is, and that gives you your final answer. Okay, so we have solved it. We have solved the equation, one-step equation, for p equals 17. But now we need to check our work to make sure that we did it right. So over here, you're gonna write the word check. So every time you perform algebra, you wanna make sure that you are doing it right. And by checking your work, you actually almost don't need me to check your work because this lets you know if you did it right or if you did it wrong. If you did it wrong, well then go back and change something, right? This lets you know if you're gonna get 100% on your test or not, or on your assignment, right? So might as well check it. Take the extra couple minutes, plus I need you to do it. So check. You always start by writing out your original equation again. So this was what the original was, 4p equals 68. And then we want to now fill in what we know, okay? So p is 17. We know what it is now, okay? So instead of writing p, I am going to write 17. And I am putting it in brackets because if I just wrote this, now the number is 417. And that's not what we want. We want 4 multiplied by 17. So you could do it like this with a dot, or you could do it like this, right? All those mean the same thing, okay? You choose. I'm choosing brackets. So 4 times 17 equals 68. Now, what is 4 times 17? Okay, we did just do this, and I know we did it properly. So we know it's 68. If I were you, I would reconfirm your work from before, punch it into a calculator, again, just to make sure, and 68 is our answer. So see how I'm working down the page? 68 equals 68. If these two sides are balanced, if they are identical, that means you did it right. So you give yourself a literal check mark, okay? So that's how you check your work. So what that all means is 17 is your answer. You're checking it over here. You know 17 is correct because it balanced, okay? Balanced with 68. Alrighty, we're gonna do another example just to make sure that makes sense. Actually, we're gonna do 2 more. And I'll share a little secret with those of you that are still listening to me. The 3 examples that I am doing on the board right now are from your worksheet that you are going to work on after this. So they're not 1, 2, and 3, but they're one of the questions in your worksheet. So you have 3 less questions to do, but you still have to show it to me. But now you know that you got those 3 right at least. Okay, so I'm gonna erase these. If you didn't get that written down, just back up. Question number 2. Okay, 2 plus x equals -2. So again, we want to isolate the variable. So x is what we are trying to solve for. So we have right now 2 plus x, or in other words, x plus 2, right? Doesn't matter which way you say it. So what's the opposite of adding 2? It's subtracting 2. So that's why I'm just gonna write a little subtract 2. Whatever we do to one side, we have to do to the other. So if I'm subtracting 2 from 2, what do I get? In this case, I get a big fat 0. So 0 plus x, or just, again, x, okay, equals. This is where, back in the fall, we learned about integers. So I have my number line up here. Remember, I'm always referring to if you're adding, you're going up. If you're subtracting, you're obviously going down. And in this case, we are starting at -2. So what is -2 minus 2? Well, you're still going further to the left, right? So -2 minus 2 is -4. Okay, so this is your answer, but we want to make sure that we did it correctly. Because I can see some of you maybe making some errors when you're adding or subtracting integers. That's fine as long as you catch your error, right? You want to make sure that you're learning and you end up with the right answer. So catch your error, and a way to do that is by checking. So here we go. Okay, so again, always start with your original equation. Make sure I wrote that down right. And now we're going to fill in what we know. So rather than writing x this time, I'm going to write -4. Okay, so I'm still going to keep my plus sign. Okay, and now I'm going to write -4 equals -2. So now here's more algebra, or sorry, more integers. So we're starting at 2. Okay, so on your number line, 2. Now we are adding some negatives. Okay, so we are adding, so you might think, okay, well, we're going right. But no, we are adding some negatives. Negatives make things smaller. So when you're adding negatives, you're going to go to the left. So 2 plus -4, you go backwards. You're going to end up at -2 again. Okay, so -2 equals, carry this guy down, -2. So did you do it right? You did. Good job. Let's say you made an error over here, which can happen. Let's say you said -2 minus 2 was 0. Okay, I'm just going to show you, this is wrong, but I'm going to show it to you. Let's say you put the answer as 0. Well, when you go over here and check your work, 2 plus 0 equals -2. Well, 2 plus 0 is 2. Does 2 equal -2? Nope. That would be wrong. So that tells you, oh, that means my x is wrong. That means I did something wrong over here. So that's when you go back and you say, where did I make my mistake? Try it again, check it again until you get it right, okay? Until you can put that check mark, okay? We're gonna do one more example together. And this is actually an important example. Not like these other ones weren't, but this one's extra important. -11n equals -55. Okay, so here's a very quick lesson for you. Grade 8s, you have heard me say this before. Grade 7s, you probably haven't. This little guy, I like to call him, can you see that? I like to call him Dopey Man, okay? Dopey is another word for sleepy. And DM are my reminders. Dopey Man, it looks like he's sleeping, right? These are two negatives, this is a positive. You use the Dopey Man for multiplying and dividing, okay? And the reason why it comes in handy for this question is I will explain it right away. But you're dealing with a -11n. In the first question, 4p equals 68, we were just dealing with a positive 4p. So you could use the Dopey Man there as well, but it really comes in handy with negatives. And I'm just gonna explain that to you right away. So you're trying to isolate n. Right now you're multiplying n by -11. Well, how do you eliminate multiplying by -11? You do the opposite operation. So you divide by -11. Whatever you do to one side, you have to do to the other. Okay, this is where the Dopey Man comes in. Okay, so whatever your two numbers are, you cover those up. So I have a negative 11, so I'm going to cover up one of my negatives on my Dopey Man eyes, and I'm dividing by negative 11. So I'm covering up both of my negatives, okay? What am I left with on my Dopey Man face? I'm left with just a positive. That means my answer is going to be a positive number. So negative 11 divided by negative 11 is a positive 1, right? 11 goes into 11 once. So we never write positive signs because when you see a number, it's a positive number. So 1n is what you're left with. And remember, 1n is the same as just n. So I am going to just write n. So same thing over here. Negative 55, I'm going to cover up one of my negatives, divided by negative 11. So we have two negatives, so I'm going to cover up two negatives. My answer is positive. So 11 goes into 55 5 times, and it's a positive 5. So there's my answer, n equals 5. Okay? Just to show you how this Dopey Man works in another scenario, if I was dividing by just, say, 11, just bear with me, this isn't accurate, but if I was dividing negative 55 just by 11, I would cover up one negative and one positive then, and then my answer would be negative. Does that make sense? So negative 55 divided by 11 would be negative 5, right? If I covered those two up, I'm left with a negative, okay? That's how the Dopey Man works. But we know our answer is positive here. Now we're gonna check it, okay? So I'm gonna erase, actually I'll just redraw him up here just so you have him around. Check. And then I'm gonna rewrite my original equation. Negative 11n, what did we solve? What did we determine n to be? 5. So rather than writing n, I am writing 5. Everything else stays the same. Now, oh, here we go. I should have saved it for this. Now, negative 11 multiplied by 5. So we have a negative being multiplied by a positive. Okay, so cover up one of your negatives, cover up one of your positives. Now, as a perfect example, you are left with a negative. Okay, so that means your answer is negative 55. 11 times 5 is 55. Equals negative 55. Did it work? Do they balance? They sure do. I love that. Isn't that just so satisfying, you guys? Like, seriously, it is. Hopefully that makes sense to you. These were one-step equations. One step just means all you had to do was like divide once, right? We divided over here. We divided by 11. That gave us our answer, okay? When we deal with 2 steps later in the week, we're obviously gonna have to do dividing, and then maybe there's another thing attached to here, like a +2. We might have to minus that 2, for example. So 2 steps. That's coming later though. So thanks for watching. Miss you all. Take a look at the questions that are posted with this video, and they are due on Wednesday. Bye.